Question 16. A car of a mass 900 kilogram is traveling at a steady speed of 30 meters per second. Against a resistive force of 2000 newtons. As illustrated, calculate the kinetic energy of the car. How to calculate the kinetic energy? You can use screen annotation. The kinetic energy formula, that is Ke equals half mv square. So the kinetic energy Ke equals to half mv square. What about the mass of the car? The mass of the car is 900. And what about the speed at which the car is moving? The car is moving at a speed of 30. So half 900 into 30 square. So that will be 405,000 joules, or we can also say 4.05 into 10 to the power 5 joules. So that is the kinetic energy of this car. The next part, calculate the energy used in 1 second against the resistive force. So how we can work out how much energy it used against the resistive force? The car is moving at a steady speed. So if the car is moving at a steady speed or a constant speed is there, so we need how much work is done against so work done against the resistive force. Work done is the product of force multiplied by distance. Power is work divided by time. Yes, you can use that as well. So, or work is force multiplied by distance. Yeah, that's right. You can use this formula, like power is work over time. So work will be power multiplied by time. Or you can also do this. First, you work out the work. How you can calculate the work done? It's force multiplied by distance. So how much force is applied? The resistive force, it's 2000 Newton. Multiply by distance. How we know the distance moved? Because we have the formula that speed is distance divided by time. The car is traveling at a speed of 30 meters per second. So speed of a car is 30. Distance we don't know. And the time is 1 second. As I mentioned here. So what is the distance travel? So the distance travel will also be, distance is speed multiplied by time. So it will be 30 multiplied by 1, or we can say 30. Because every second, if its time is 1 second, so it means the speed and distance will have the same value. Like every second, it will cover 30 meters. So 2000 multiplied by 30. So it will be equals to 60,000 joules of energy. So how much was the kinetic energy? The kinetic energy was 405,000 joules of kinetic energy. And the work done against the resistive force was 60,000 joules. Like this is much energy is against the resistive force used. Next is, what is the minimum power that the car engine has to deliver to the wheel? Because the car is moving at a constant speed. So minimum power, like here we calculated the energy. We calculated like 60,000 joules of energy is needed. So 60,000 joules of energy is needed for that. as we want to maintain a constant speed. So if we are using, like example, 60,000 joules of energy is a resistive force, like 60,000 joules of energy is used against the resistive force. So how much force the engine, or how much energy the engine has to consume so that the car will travel at the constant speed. So the car has to, the engine has to deliver 60,000, but they ask for the power. No, not 12,000. It should be 60, because see in the question, in the question, the energy which is wasted against the friction because of the resistive force, how much energy was wasted? 60,000 joules of energy was wasted. So how much energy the engine or how much energy every second the engine has to produce so that it maintain a constant speed? So the minimum energy it has to generate is 60,000 joules per second. So minimum energy it has to generate is equals to 60,000 joules every second. And why we need the same amount of energy? Because we want to maintain a constant speed or a steady speed. So if I want to maintain a steady speed, same amount of energy, the minimum energy the engine has to apply to maintain the steady speed. That's why the answer is 60,000. What form of energy is in the fuel used by the engine to drive the car? So which form of energy is there in the fuel? It is a chemical energy. So that's a chemical energy. And state why the energy in the fuel is converted at a greater rate what we have calculated. Like we calculated it has to be 60,000 joules every second. But practically it will use more. What is the reason for that? Because not all of the energy is used to move the car. Some of the energy is wasted or lost in the form of heat and sound. That's right. Because like the engine, when it produce, take the chemical energy input and move the car, it's not only moving, the car produce sound as well. So it is lost as a heat or as a sound energy. In question 17, figure 3.1 shows a descent of a skydiver from a stationary balloon. So there's a skydiver at an altitude of 2,000 meters, and he's moving at he dives from the stationary balloon, and then he used a parachute at a height of 500 meters. The skydiver steps from the balloon at a height of 2,000 and accelerates downward with a speed of 52 meters per second at a height of 500 meters. And he then opens the parachute from 400 meters to the ground level. He falls at a constant speed. The total mass of a skydiver and the equipment is 92 kilogram. Calculate the loss in gravitational potential energy from 2000 to 500. So from 2000 to 500, like how much energy has changed? The skydiver was at an altitude of 2000 meters and he opened the parachute at a height of 500 meters. So how much gravitational potential energy he lost? Potential energy is mass into gravity into height. The mass is 92, the gravity is 9.8. And what about the height? The change in the height will take, because it started from 2000 and at 500 meters he reached. So how much the height changes? It's 1500 meters. So this will be the energy, the loss in the gravitational potential energy. Then calculate the kinetic energy at 500 meter. At 500 meters, we know the speed of the skydiver, it is 52. So the kinetic energy will be equals to half mv square, where mass of the skydiver is 92 and the speed at which the skydiver moves, that is 52. So this will give us the kinetic energy of the skydiver. So when the skydiver jumps, that is 124,384 joules. And the next part, they will ask like how much energy is lost. So the gravitational potential energy when he jumped, it was this was a gravitational potential energy. And at this point, he's having a kinetic energy of 124,000. So if we need the next part, they ask like how much energy is lost because of the air resistance or the friction. So how we'll work out, we'll just take a difference of the two energy to know how much energy is lost. The next is the kinetic energy at a 500 is not equal to the potential. What is the difference? Like if I say the gravitational potential energy for the skydiver, let's say 100 joules. So when he is falling at 500 meters, he should have a kinetic energy of 100, but he's not having 100, he's having less than 100. So what is the reason for that? Why the kinetic energy? So why this? So because some of the energy is lost because of the air resistance or the friction. So as this skydiver jump, his some of the energy is wasted or lost in the surrounding because of the air resistance. That's why the gravitational potential energy and the kinetic energies will not be same. So due to some work done against the air resistance, now before he opened the parachute, like what will happen, the air is opposing his motion. So that's why he will lose some of his energy to the surrounding because of the air resistance, or some of the work is done against the air resistance. That's why the potential energy is not equals to kinetic energy. If there was no air, like if we ignore the air resistance, if there was no air, if he's having 100 joules of energy here, at this point, he will also have 100 joules of energy. But practically, it's not possible because air opposes the motion, so some of the energy is lost to the surrounding in the form of heat, or you can also say sound, or some of the work done against the friction or air resistance or a drag, you can also say that. Then what happened to the air resistance acting on the skydiver during a fall? So air resistance will increase because as a skydiver jumps, his speed increases, so air resistance will also increase. And what is the value of air resistance from 400 meter to the ground? From 400 meter to the ground, he's moving at a steady speed or a constant speed. So when he's moving at a constant speed, then what will happen? The weight of the skydiver, which is acting downward, balances with the air resistance. So what is the weight of the skydiver? It will be same as the air resistance. So weight is mass times the gravity. So weight is mass times the gravity. So the mass of the skydiver is 92 and the gravity is 9.8. We multiply, we get the air resistance as same as the weight, which is 901.6 newtons. Is it clear, this question? So next we have on a day with no wind, a fountain in Switzerland propelled 30,000 kilograms of water per minute. Per minute means how many seconds are there? Time should always be in second. So in 60 seconds, what is the unit of air resistance? Because it's a force, so the unit of the any kind of force is Newton. That's why we'll write Newton there. So if you need the potential energy, we need the power here. How we can work out the power, the formula for the power. Power is work divided by time, or power is energy divided by time. So which form of energy he will have? He will have a gravitational potential energy divided by time. The gravitational potential energy is mgh divided by t. So 30,000 times 9.8 times the height, which is 140, and divided by time. Remember one thing, any kind of a question, the time should always be in seconds. So 30,000 into 9.8 into 140 divided by 60. This will give us the unit, this will give us the power in watts. So mass times the gravity times the height. When the number is too large, so you can write in exponent, you can say 6.86 into 10 power 5 watts. In part B, the efficiency of the pump which operate the fountain is 70%. Calculate the power supplied to the pump, the input we need. Like the output is 6.86 into 10 power 5 watt. We need the power supply. Like there's a pump. The pump is used to push the water up. The water has a, like the power which is output is 6.8 into 10 power 5. We need the input one. How much energy supplied to the pump. So the formula for efficiency is the total output divided by useful output divided by total input into 100. So it's 70% efficient. Output is 6.86. 6.86 into 10 power 5. Input is unknown into 100. So this will give us, the X will be 6.86 divided by 70 into 100. Which is, what's the final answer for this? (6.86) exponent. No, it's not multiply by 70. That's a mistake here. You cannot do multiplication because 70 is we cross multiply, so this should be divided by 70. So X will be equals to 6.86 into 10 power 5 multiplied by 100 divided by 70. That will give us the total input power. And the last one, on another day, the horizontal wind is blowing. Water does not rise vertically. Why the water still rises to a same height? Because the input power is not changing. Like we are supplying the same, the water does not rise. There's a wind which is blowing horizontally. So wind is pushing the water horizontally, but it rises to the same height. What is the reason why it rises to the same height? Because same amount of power is supplied to it. Like wind is not opposing the vertical motion. That's why. So the wind is blowing horizontally. It does not affect the vertical motion. That's why it rises to the same height of 140 meters. So the wind has no effect on the potential.